Hello and welcome to this tutorial. So today we are going to take our tutorial on function block diagram. Okay, so we will create a new program. My programming language is going to be function block diagram, and I will press OK and wait for my window to load. Wait for some more time. Okay, so this is our programming window, and with the help of function block we do the programming in the function block diagram. First we are going to enter one AND block. Okay, and press enter. Okay, so this AND block has two inputs and one output. Okay, we are going to enter one M0 bit here, and let's take it here, and I will connect this to the input. Okay, this I have connected to the input side, and here I will take one M1 and I will arrange it, and I will assign this M2 to the input 2. Okay, and for this output I am taking one M3 bit here. Okay, and I have connected this to the my output section. Okay, so I have completed this AND block, and I am going to enter one OR block here. Okay, so for the this OR block we also have two inputs and one output. Okay, so with the help of actual simulation we will understand what is the difference between this AND block and this OR block. Okay, so I am going to take one M4 here and one M5 here and one M6 I am going to take here, M6. Okay, so let me connect this to input 1, and this I need to connect to the input 2, and this to the output. Okay, so we have completed. Let us rebuild our logic, and we will start the simulation, and we will observe how this and OR block is functioning. Okay, so now we are in the monitor mode. I will click on the M0 and I will press shift and enter. Okay, so M0 is true, but M3 is not on. Why? Because this is the AND block. We need two inputs. Two input should be true. Okay, so then only my M3 will be on. Then only my M3 will be on. And for this OR, we need only one input from this M4 or this M5. Okay, so if one input will turn on from these two, so then my M6 will be on. Okay, so let us first turn on M1, shift and enter I will press. Okay, so my M3 is now true. Okay, and for this M4 I will just turn on only M4, and my M6 is true. Okay, so this is how OR block is going to be work. Okay, and I will just turn this on, and I will turn this one on, this M5, and I have a output. Okay, and if I will turn this M1 from this, so I will not have an output, because I need two input should be true for this, and for this OR block I need only one input. Okay, so this is how you can use and OR function in your function block diagram programming. Okay, so now we are going to discuss about the uh, T on and T off, on delay timer and off delay timer in the function block diagram. Okay, so first I'm going to take one input from here, and I'm going to enter T on. Just simply I will enter T on here. Okay, and press OK. So this block will appear. Okay, so this T on timer, when you will provide input at this section, the preset value in this section will turn on, and after the specific time provided, this Q will be turned on. Okay, so I will specify one T here. I need to T T has and 2 seconds. Okay, so this I have created here. Okay, and this Q, so we will take one M4 here, M5 we have taken here, and we have connected this to the my output. Okay, and this time I have converted to my preset time. Okay, this elapsed time we will neglect. Okay, and let us online. Okay, so we are not in the simulation mode, so I need to convert this data and I need to start the simulation again. Okay, so wait for some time and we are good to start. I will press shift and enter to the M1 and this timer is running, and after this 2 seconds this M5 is now true. Okay, I will just turn this off and turn this on again, and for the 2 second, after 2 seconds this is turning on. Okay, so this is how my T on timer is working. Okay, let me turn off the simulation and I will take one T off timer here, T off timer. Okay, and just enter here and I will convert, I will take the input from this M0. Let me, okay, so it has taken the input from this, and this preset value I will take T as, okay, let's take 3s here. Okay, and we need to connect this to this specific time, and this Q output I will take to the, okay, so let us not take this line, let us not take this line. Okay, we will take input from this Q, this bool output. Okay, this Q, we will take the input from this. Okay, so let me enter T on underscore 1. Okay, and dot q. Okay, so this I will take here and I will just connect this. Okay, when this will turn on, so then this input will be turn on. Okay, so we are going to discuss about this T of timer. Okay, so this T of timer is going to be work like that. When this input will be provided to this T of timer, so then suddenly this output will be on. Okay, and when this will turn off after the specific 3 second, this timer will turn off. This is how it's going to be work. Okay, so let me start the simulation. Okay, so this is not converted. Okay, so we need to first convert this data. Let me convert this, and it has no errors, and again start the simulation. Okay, so start the simulation. Okay, once again I will dictate my condition. Okay, for this T off timer, when this input will be on, so this output will be instantly on. Okay, and when this input will be turn off, okay, after 3 seconds this will turn off. Okay, so let me turn this on. Okay, so this is now on, and this output is now on. This Q of this T of timer is on. Okay, and when I will turn this input Q off, then my this timer will off, and after this specific time this Q will be turn off. Okay, so let me turn M0 off and observe. Okay, so this is now running and this is on, and after 3 seconds this has to turn off. Okay, so this is how you can use the T off timer in your function block. Because the counter up and counter down function in the function block diagram, I will enter one counter up function here, CTU, and enter this, and first we'll understand the function. So these are the input areas. So this counter up, this is the input for this counter. This R is reset, this is preset value, and this Q is output, and this is the current value. Okay, I will take one M0 here. M0 I will take and I will connect it to the counter up, and I will take M1 for reset it. So M1, just I will insert here, and the preset value I will enter 3. So 3 preset value I need to assign it to the input side. Okay, this current value let me register with the D0. So this D0 will always have the value of the current value of this counter, and this output, let's say I will connect this to the M5. Okay, and I will just convert my program and see if this is working or not. Okay, so when I will just turn this counter on, this M0 on, so this will start counting, and when this will complete the counting to the 3, so this output Q and this M5 will be turned on. Okay, let us start the simulation and wait for my program. Write to the PLC, and from here I will press shift enter. So you can see this current value is getting registered to this D1, and this counter up function is working. Okay, run this again, and this is 2 and the preset value is 3. So when this value will equals to 3, this Q and M5, this will turn on. Okay, so let us do one more time. Okay, so now this Q is true and this M5 is true. Okay, so this is how you can use the counter up function. Okay, and the second function we are going to enter is the counter down function. So we will come here and CTD we are going to enter here, and okay, so same. So this CD is the countdown function, and this is load. Okay, so you need to load. You will enter your preset value here. Okay, and when you will press this load button, so this will be assigned to this current value. Okay, and when you will give input to this, so then this will start countdown. Okay, so when you will give the first input to this, so this will give instantly the output. Okay, and when this countdown is finished, so this your queue will be turned off. Okay, so I will just give only uh, 2 count value to this preset. I will connect it, and I will load with this M8. Let's say by M8 I will load this counter, and I will take the input from M10. Okay, from M10 I will take the input and this Q and this current value. Okay, let's neglect them because we are not going to take the output from this. We will just monitor this Q only. Okay, just rebuild my whole the program and start the simulation. Okay, so now we are in the monitor mode. Okay, so I will just turn this M10 on. Okay, and when this is off, okay, so I have not loaded this preset value to this count value. Okay, so I just turn this load button on. Okay, when I will turn this on and off, so this will be load. Okay, and I will just turn this M10 is true. Okay, so this has countdown. Okay, and I will turn this off. Okay, and this is okay. So when this uh, counter value is equals to 0, so then I have the output in the queue. Okay, so this is how the countdown is working. Okay, and okay, so I need to reset this. So for resetting it, I will just load this. Okay, so this is now resetted. Okay, so this is how you can work with the count up and count down function in the function block diagram. Okay, now we are going to see the math function in the function block diagram. So I will add one add function here and one sub function here, and I will add one multiplication function here,
and I will add one division function here, div I will add here, and I will assign some random number to this. I have, so this 3 and this 4. Okay, so we need to just connect these to the input. Okay, and for the subtraction I will take 10, and I need to connect this 10, and we will take 5 here. Okay, so this is how you can take your inputs, and this 15 and this 3. So we will just connect it, and for the division we will take 50 and take this 50. Okay, we have connected this 50 here, and we will take 5 here. Okay, so 5 we need to connect here, and let's say I will register this to D0, register this to D0, and this D1. Okay, I need to connect D1 to here. Okay, and this is D5. D5 let me take here, and this D10. Okay, and when I will start the logic, and let me convert this data and start the simulation. Okay, okay, so now as you can see, the data register have the value of 7 because 3 plus 4 equals to 7, and in the subtraction 10 minus 5 equal to 5 in the D6, and this 15 into 3, this 45 is here, and 50 divided by 5, so this is 10. So this is how you can use math function for your function block diagram.
Works 3. So I will take one D21 here. So this is my data register in which I will enter my inputs, and D22 here. So both we have taken here, and this I will take GE greater than equals to. This is one math function. Okay, and this is equals to. Okay, this EQ, and this is not equals to any is for not equal to. Okay, and greater than equals to not equals to, and one more function we need to enter here, greater than equals to not equals to, and let's say le I will enter here less than and equals to. Okay, and I will connect all the data register to the input, and this input I will connect with this one. This will I will connect with this one, and this I will connect to the this one. Okay, and input 2 I will connect here. Okay, and input 2 here, and say here. Okay, and here I will take M51 here, M52 here. Okay, so this is 51, M51. This is M52. This is M53, and this is M54. Okay, and going to connect with the output. Okay, so this I have connected here, this connected here, this connected here, and the last one I will connect it this here. Okay, and just going to convert my program, and I will write the program to PLC and start the simulation. Okay, okay, so as you can see in the greater than equals to, I have, okay, so we are not able to distinguish between these, so just I need to place it here, and this I will place here, and this I will place here. Okay, and let me rebuild this all because location has changed, and we are good to go again. Okay, and let me just register this.
Okay, so this I need to register here. Let me register this to watch window. Okay. So now we are in the watch window and we need to register D1, D21 and D22. Okay. And we are going to monitor the value for the all windows. Okay. So first we need to understand this greater than and equals to function. Okay. So we have enter one greater than equals to function and we have input one. This D21 is connected with the input one and D22 is connected to the input two for each of these function. Okay. So we are going to understand this first function. If D21 is greater than or equals to D22, then we will have output. Okay. So let me just so this is equals to 0 0. So that's why we have output. Okay. So let me just do D21 greater than D22. So we have output because still this greater than equal to condition is getting fulfilled as soon as I change the D20 to the higher of D21. So we will not have a output in the M51. Okay, so this is how it is working, and for this equals to, so these both D21 and D21 need to be equals to. Okay, otherwise we will don't have output. So if I will just enter the value for this D5 equals to 5, then only we will have the output. Okay, so this equality function is working like that. And not equals to means if this is not equals to, if I will just randomly change. Okay, so when this D21 and D20 will 22 will not be equal, so then we will don't have the output. We will have output in the M53 because it is not equal to. Okay, and less than equal to, let me just try it for equal to function. Okay, so this equal to function is working really well for this LE function, and I will make the D22 less than. Okay, less than, let me take 4. Okay, oh D21 should be less than. Okay, I will just, okay, so I have entered D21 less than D22, then we have an output. Okay, and I will increase it. Okay, so then we will don't have output. So this is how you can use the math function in the function block diagram. Going to understand the rising edge and falling edge. So as in the function block diagram, we have already understand the function. Okay, so now I will enter the syntax for the rising edge and falling edge. So I will r underscore trig trigger. So this is my rising edge. Okay, and I will take one counter of function here so that we can check the this is working or not. Okay, the preset value I will take, just say 5. I will take the preset value, and this I have connected this one M65 and this F trig F underscore trig. So this is going to be my falling edge, and I will take one more counter. Okay, to count it. So this is working or not, and so this we are good to convert this and just start the simulation. Okay, so this M64, when I will turn this M64 on, okay, so this R trig is going to generate one single pulse to this counter. Okay, and same as for the falling edge instruction. So when this M65 is will be true, and after true, when it will turn false, so then it will trigger one pulse to this counter. Okay, first we do this. Okay, so this is how it is working. This has started the counting. Okay, no matter this is true. Okay, so when this R-trig function has received one true signal, so it will generate one pulse. Okay, and then it will turn off this output of this Q, and this will always be false. Okay, so just do it again. So this is generating the pulse. Okay,
and this M65. So this is true, but it has not released the pulse. Okay, and when I will turn this off, then it will release. Okay, so this is false. Okay, so we have not defined the preset value for this counter. That's why it is not working. Okay, so we will firstly assign this 5 to this counter and convert this and start the simulation. Okay, then it will only start the counting. Okay, so now we are good to start, and so this is true, but this is still 0. Okay, and when this will turn false, then only this will generate one output. Okay, okay, so you can see when this is turning false, so this is generating an output. Okay, okay, now okay, so this is how you can use this rising edge and falling edge for your function block diagram. Okay, now we are going to see the inverse and ALT function. Okay, so let me take one input here, this M1, and I will add one inverse function here. So this inverse I will add, and I will take one M2 out from this. Okay, and one ALT function. ALT function I'm going to enter here, and I'm going to take one M3 from this. Okay, just connect my all the bits to these function, and this M2 I will connect here, and I will take this here. Okay, so let us first understand the inverse function. Okay, so when this input will be true, so this will inverse the output. Okay, when my M1 will be true, so this output will be false. Okay, and when this one will be M1 will be false, so this will be always true. Okay, and this ALT function is going to oscillate the output. Okay, oscillate the output. Let's take the M4 here and connect with this one. Okay, and let us rebuild this and start the simulation. And I need to turn the M1 on, so I will just connect with, I will take this in the watch window. Okay, so this M3 is true. Okay, so this is oscillating, M4 is oscillating. Okay, so this is how this ALT function is working. Okay, and this inverse function, so this M1 is false, so it is now true. I will just turn this M1 M1 on, so this will off. Okay, so let me just turn this M1, and now this is off. Okay, and this ALT function, this is working, this is taking the last output. Okay, so when this M3 was, this M2 was uh, true last time, so this has taken the last condition. This true was the last condition of this. Okay, and again I just turn this on, turn this off, so this will be true. So this is how the inverse and ALT function is working. Okay, so now we are going to understand the set and reset functions. So I will enable set. With the help of this M1, I will set the M2, and with this M3, I will reset. With the help of this M3, I will reset the M2. Just need to connect this one and connect this one, and this one is to connect here. Okay, convert my program and start the simulation. Okay, just M1 turn on and off, so this has set at this M2. Okay, just enable this M3 and turn this off, so this M2 is now resetted. So this is how you can use the set and reset function in the function block. Okay, now we are going to understand the move and demove function. Okay, I will enter one SM8000 here, and
one move function here, move, and with the help of I will move this 100. Let's take D5 here and connect this and move this to D10. Just connect this. Okay. And one demove function here. Demove, enable with SM8000 and input, input. This going to be the double word type data. Okay. And this input I'm going to assign here and output double word data. Okay, and let's convert this, and I have not connected this output. Okay, convert this and start the simulation. Okay, let me register this to watch window and just zoom this out. Okay, and just here, move it here. Okay, perfectly fine. Okay, so I will just enter the values for D5 and check if it is transferring this or not. Okay, so this value, so this is transferring, this is moving from D5 to D10. So this is working okay, really fine. 32,000 I will enter here. Okay, so this is transferring. Okay, and beyond the 32,000, this I think this will not work. Okay, and this demove we have take the double data here, and this I need to register here. Okay, and can I go beyond? Yes, beyond 32,000. So with the help of double move, we can work with the 32-bit data. Okay, and in the move function, we can only use with the 16-bit data. Okay, this is how you can use move and demove function in your